Okay, so we're going to be looking at describing our own transformations, first of all using function notation, which I think you should be pretty good at, and then we're going to look at one to do with algebraic expressions, which I think is perhaps a little bit more challenging. This is a really common way that they ask these kinds of questions, so we're just going to kind of go straight in. I'm going to do this first one here. I want you to pause the video and try these remaining four that you've got, but I'm just going to do just the first one to start with. So it says, given that the blue curve is y equals f of x, describe the transformed red curve in function notation. So you can look at this blue curve that we've got here. It should be pretty clear to see that most of the points have moved downwards 2 spaces. Well, I say most of the points, every single point has moved downwards 2 spaces, which means I would represent that as y equals f of x minus 2 because it has moved down 2 spaces. Now, I want you to try these four that you've got here, so pause the video and have a go at them. This one's pretty special because I think there's 2 ways that you could describe it, so I'm going to do that one last. Okay, so this one that we've got down here, the blue one has moved 1 space to the right, so it's going to be y equals f of x minus 1 because it's moved 1 in the positive direction, so you make sure you do it like this. This one that we've got down here, hopefully you've recognized what this original blue curve is. The blue curve that we have originally is y equals cos x. You may not have come across that curve, you don't need to know it to be able to do this video. And it looks like everything here has actually shifted. The bit that was at 90 has shifted across to 45, 270 has gone to 225. You can see that everything has shifted back. The 180 has gone to 135. Everything has shifted 45 to the left. Now, if something has shifted 45 to the left, we would say that it is going to be x plus 45. Although we've been doing things with like units of just like 1 or 2 or 3, you can have entire graphs moving much bigger sections if there's a lot more on the x-axis. So it looks, it's moving 45 to the left. I'll do this one next. It is a reflection in this line here. We've got a kind of a vertical flipping. Vertical means it's going to be the negative outside. So it's y equals minus f of x, like this. Now this last one, there's 2 ways of doing it. You could think about it as this reflection in this line. I'm going to call this part 1. We could call it y equals f of minus x, because you can see that the blue has reflected in the y-axis to give the red. Or you could think about it in a slightly different way. You could actually see how each of these points from the blue has moved 1 space to the left. So if it's moved 1 space to the left, you could say that it's y equals f of x plus 1, moving 1 space in the left direction. This one has 2 different ways you could express this. Sometimes the question will say translation or reflection, so you're kind of forced to be able to give it in a particular way. Then it's asking a different way. It sometimes wants us to describe transformations, but not using all of this function notation that we've got here, instead using algebraic expressions. So instead of using function notation, if we know the equation of the original curve, we can instead describe the transformed curve algebraically. I'm going to do 2 examples, and then I want you to try the third one yourself, and then that's the end of this playlist. Most of these things I've been doing, by the way, are exactly the style that it would be asked in an exam, so I'm not going to do like a separate exam style one. Pretty much this whole topic is how it would come up in an exam. So the example says, curve A with equation y equals x squared minus 2x plus 4, which I've drawn here, is translated to give curve S. The turning point, 1, 3, is mapped to 4, 3. Find an equation for S. So it's definitely a translation, which is good. So if we said that this original one that we had here was y equals f of x, and this is for curve A that we've got, we're now going to think, what would it be for curve C? Well, they've said that the turning point, which is 1, 3, is going to map to 4, 3 instead. Now, I'm not going to be too bothered about how accurately this is going to be drawn, but it's sort of going to be looking like this. So it's pretty clear to see that this curve has mapped with it moving 3 spaces to the right. 3 spaces to the right is what's happened as this translation. So the way we represent that with function notation is going to be f of x, not plus 3, but minus 3 instead. So because it wants us to find an equation for s, that means we need to come up with what is f of x minus 3. Well, the original curve is y equals x squared minus 2x plus 4. That is what f of x is. We're going to be changing the input now from x to x minus 3. So this is for curve A, Now we're going to do for curve S, I'm going to replace that first x with an x minus 3. I'm going to replace that second x with an x minus 3, and there's no x in that last part, so I'm just going to leave it there. Technically, this is correct. You don't need to go any further. We have found an equation for S. But I'm going to go and do a little bit more just to show you what the algebra would be. So I'm going to do this expanded brackets here is going to be an x squared minus 3x minus 3x, that's minus 6x, and you get the minus 3 times the minus 3, which is 9. Expanding the next bracket, you get minus 2x, but carefully you have negative 2 times negative 3, which is positive 6, and you have plus 4. So just tidying this up, you're going to have x squared, you have minus 6x minus 2x, which is minus 8x, and then you have the 9, the 6, and the 4, which is 19. So you've got x squared minus 8x plus 19 is going to be this red one that we've got here. Okay, another one that we've got, it says curve B with this equation is translated to give curve T. The turning point 1, 3 is mapped to 1, 0. So this turning point 1, 3 is now going to be mapped to 1, 0. Well, I don't really need to draw like the whole curve, but the whole curve would look something like this. Clearly it has moved 3 spaces downwards. So if the original one is f of x, if it's moved downwards, the new one is going to be f of x minus 3. This one is a lot easier to do, because if curve B is y equals x squared minus 2x plus 4, curve T is just going to be this one, the entire function, but just with an extra minus 3 on at the end. So it's going to be x squared minus 2x plus 4 minus 3. Because of this minus 3 being after the function, it just gets done after the equation. So simplifying that, we get x squared minus 2x plus 1. That is going to be the equation for that. So I want you to try this very last question that we've got here. It says the curve C, with the same equation as before, it's exactly the same curve, is reflected to give curve U. It's going to be a reflection now and not a translation. The turning point 1, 3 is mapped to minus 1, 3. Find an equation for U. So pause the video and have a go, but I'm going to go through this one right now. So the turning point 1, 3 is mapped to minus 1, 3, and it's a reflection, so we can pretty much see, well, if I can draw it better than that, we can see that the curve is going to look something like this. It's clearly a reflection in the y-axis. So if the original one is y equals f of x, then the new one is going to be y equals f of minus x. It's that kind of horizontal flipping that we've got here. So that means we are going to take the original equation and we're going to replace every x with a minus x that we've got here, okay? Let's just get in a new page so I've got a bit more space. So the original equation for C is y equals x squared minus 2x plus 4. But for the curve U, if I put in a minus, it would be a minus x squared, a minus 2 multiplied by a minus x, and a plus 4. Well, negative x squared is just going to be x squared. Negative 2 times negative x is positive 2x, and then there is a plus 4 at the end. So the equation of U is this one that we've got here. So you can see this one's got a little extra stage. You have to find the function notation, and then you have to do the algebraic part. And the algebraic part we did in the very, very early parts of these videos, where we looked at the algebraic expression as a bit of a summary. So pretty simple when you look at it on this page. You're like, oh, cool, it's just a few things that I need to learn. But actually the applications, there's a number of different ways that they can ask these questions. So that's the end of this part here. I hope you've enjoyed this and that it's helped you get on with things. And good luck with your studies. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. This is the end of the playlist, but head to my channel's homepage to see what else I might be able to help you with. And as always, wishing you the very best for all your studies.